nessun problema. Abbiamo qua la chiavetta.
Monaco.
Abbiamo già la chiavetta se non... Ah, no, a posto. Quale prende?
No, no, la PowerPoint.
PowerPoint? Ah, ok. Okay, welcome back to start the afternoon session of this second day of the symposium. And I would like to swap a presentation introducing first Professor Jingye Yan. He's a member of the National Space Science Center of the Chinese Academy of Sciences. As you can see, the title of his presentation is DSL, a low-frequency radio interferometric imaging mission using Farside of the Moon. So I would like to invite Professor Yan to the stage. And this is the pointer, if you want to use this for the laser, and this to go back and forth.
Okay.
So let me just start with this. Please, the stage is yours.
Okay, many thanks for this invitation. It's a great pleasure here to introduce a particular lunar mission we proposed in some 10 years ago. DSL stands for discovering the sky at longest wavelengths. So it is a very low frequency imaging mission. We are not landing on the far side of the moon. Instead, we insert the circular orbit around the moon and use far side segment to make radio astronomy observation. So my talk will introduce briefly the DSL mission and following development schedule, and also the topic for this symposium, how to protect the far side of the moon. So as introduced by several previous speakers, the major, most attractive scientific objective is the early phase of the universe, the dark ages and cosmic dawn. For these two periods of the universe, this mission are going to monitor the variation of the global spectrum. The variation is very, very small. For the cosmic dawn, the variation is around half Kelvin, and for dark ages, the variation is only 50 millikelvin. So as compared to the foreground radiation, which is about 10,000 up to 10 million Kelvin, this variation is very, very tiny. So sensitivity is actually a critical requirement for such kind of mission. That's why for the surface array in the far side of the moon, people require 1 million antennas on the ground. But for this orbital mission, we can do is to increase the integration time to improve the sensitivity time to time. And the second objective is to make sky map in very low frequency or ultra long wavelengths. This is actually an open window in these very low frequencies. We don't know even there is a strong independent sources over the sky, unless other frequencies, for example, the microwave wavelengths, we can see many sources over the sky, but for this low frequency, actually almost we know nothing about our universe. The third objective is to monitor the propagation of corona mass ejection from the sun to the Earth. Last year, we built a new telescope in west part of China. The name is Daocheng Radio Telescope, which is composed of 313 antennas, each of aperture of 6 meters. The diameter of the array is 1 kilometer. The objective for this telescope is also to image the solar activity in a manner of a three-dimensional evolvement. Like the bottom image, it is a real measurement using this telescope. And a few days ago, we are fortunately to monitor this kind of filament eruption. So it is a very successful telescope. So this linear array is proposed in 2014. My team proposed this kind of mission concept. And in 2015, we conduct a joint research together with European colleagues. And in 2016, we start to build a pair of microsatellites. It's called Longjiang 1 and Longjiang 2. And in 2018, both satellites was launched into space. Unfortunately, only Longjiang 2 arrived at lunar orbit. Therefore, it is unable to make interferometric measurement. We take only spectrum in lunar orbit. So there are several advantages for this linear array besides the engineering feasibility. Technically, for this linear array, the communication between satellites and also baseline measurement and clock synchronization is much easier than other type of array. In any instant, we can take this kind of UV coverage. It is a very thin stripe. And over 2.3 hours, actually, we can create a perfect dish coverage. So every 2 hours, we can have a very nice image in the normal direction of this dish. After 1.3 years, we using also the orbital plane precession. After 1.3 years, the precession make a complete period. Then we can create this kind of UV coverage. It is very, very dense, and almost the projection area is similar in any direction over the sky. This means we have a very high angular resolution in any direction. So here is the mission profile. We have 3 scientific objectives. We use 10 satellites, 1 mother, and 8 low-frequency satellites, and 1 high-frequency satellite. This high-frequency satellite responsible for the spectral measurement of cosmic dawn. And the low-frequency will take care of dark ages and also Oscar map and Sun-Earth system. And in 2018, we gained this kind of measurement in lunar orbit by piggybacking Chang'e 4 mission. So here is the experimental satellite. We put antenna here and here. The top one is provided by the Polish Academy of Sciences, and the bottom one is manufactured by our institute. Here is the measurement in lunar orbit. Everybody maybe knows in Chinese Chang'e 4 we have 3 low-frequency instruments, and this Longjiang 2 actually take the best spectrum in low frequency. So it is the first in the world to using distributed platform making interferometric images. So we make a drone flight experiment with 3 drones. and make this kind of a movement, which is very similar to what we will have in lunar orbit. And we have this dirty image, and after clean, we can see very clear separate sources on the ground. This two source is artificial source unproposed. And the main parameter, we are working between below 30 microhertz down to 10 kilohertz. And we make baseline measurement independently in real time. The accuracy is better than 1 meter. And we also using optical instrument to detect the direction of the baseline. So the accuracy is 10 microradian. And the clock synchronization is better than 3 nanoseconds, and also the sensitivity. And there are system specification for the amplitude similarity and the phase similarity. It is not very good number as compared to ground interferometer, but in space, it is already good enough. So the development schedule, we are hopefully to approved very soon. This mission will be launched in 2027. All the 10 satellites will combine as a single objective and launched by a single launcher, and as a combination insert the lunar orbit. Once we get into the lunar orbit, the mother will deploy all the microsatellites. The height of the orbit is 300 kilometers, and we choose the inclination angle of 30 degrees. And also we make a particular maneuver to change the distance between microsatellites. So this shortest baseline is around 100 meters, and the longest baseline is 100 kilometers. So very soon we will have a 100 kilometer aperture radio telescope in the space. So change the length of the baseline, we call it breath. So after 1.3 years, we will have a out-sky map of very high resolution, and also very high quality, because the UV coverage using this kind of method, the UV coverage is much better than previous proposals. And finally, we will create this kind of sky map. This is a simulation by my colleague using different frequency, and we can see the galaxy become quite different if we considering the absorption effect by the intergalaxy medium. So for the protection, because this is actually we add all 10 satellites together to become a very huge telescope. So we have to make inter-satellite communications. Also, we need to send calibration signal from the mother satellite. So inter-satellite communication and ranging, and also clock synchronization based on Ka band. And we using narrow bandwidth in low frequency domain to make inter-satellite phase calibration. The second is very, very important because unless other higher frequency, we don't know if there is a single bright sources on the sky. Even there are, the brightness of the single source must be much higher than the integration over our sky. So we have to create a calibration source by ourselves. And the communication between Earth and the Moon, we use X or K band. And also, we will set up a beacon on both the mother satellite and using VLBI measurement to measurement the position and the orbit of the array. So summaries, DSL uses all available conditions, including the moon blockage, orbital movement, and orbital plane precession. And also we design a particular mode to change the length of the baselines or breadth. And therefore, we can deliver best so far all-sky map with very high feasibility, technical feasibility, and relatively low cost. The total cost is only $20 million. And for protection, we consider disposal. And although some people here think disposal may be not the best method, but I think this is what we can so far. And in order to protect the spectrum, we are using minimum and allocated spectrums. So that's all for my talk. And due to the situation right now, several years ago, we have a very close cooperation with European colleagues. But however, any kind of cooperation is still welcome. If you are interested, you can write email to me. Thank you.
Thank you, Professor Yan, for your talk, and we have time for questions.
I wanted just to congratulate for that beautiful observation of the coronal mass ejections.
Thank you.
And I would like to ask you if by chance in these wavelengths, you know if there is some possibility to get precursors in order to use them for prediction and for alert for space weather.
Yes, the proposal for this ground telescope is going to make space weather measurements. And besides the solar observations, actually we also conducting now the low frequency sky survey. And we also try to cooperate with the 500 aperture telescope in China, the FAST, to work together on pulsar and fast radiation bursts. So there are many other applications with this huge telescope. Thank you.
Hi, Giuseppe Tomasicchio from Telespazio. Congratulations for the presentation. I have just two observations. One is regarding the altitude that you estimated for the constellation.
Yeah.
That it seems a little bit risky in terms of safety for what concerns the moon, the moon orbiter that will be there. So normally we consider 500 kilometers at least as altitude. So take into consideration Telespazio works for Moonlight project. So the other consideration is that, if I well understood, you have a sort of architecture, mother and children architecture, where you have a bigger satellite and smaller satellite that take the synchronization in low frequency. And is correct? Is a matter of synchronization between them? Is a sort of flight formation?
Yeah. For the first, the optical height of this array is 300 kilometers. So we make a very careful simulation. So in this height of orbit, it is almost permanently staying in the spot orbit. There is no risk to clash automatically onto the lunar surface. And the second is the function of the mother satellite. We make clock synchronization by the array itself, because so far we have no global navigation system in the lunar space, so everything we have to do ourselves. So this kind of measurement is to making every microsatellite synchronized to the mother satellite. So actually the error will be increased, considering we make two measurements and gain one clock or one baseline.
But do you have chip scale atomic clock on board or something like that?
Yeah, we have clock on board.
Okay, thanks.
Other questions? No? Okay, so let's thank you again.
Thank you.
So we proceed with the next speaker, Dr. Giuseppe Tomasicchio. He's the head of System Engineering and Design Authority at Telespazio. And he's going to present a presentation, a talk, whose title is Prospects on Future Moon Farside Services for the Astrophysics Lunar Observatory. Okay, so the presentation is running, and if you like, you can use it.
Yes, thank you. So thank you for the opportunity that you gave us as Telespazio to participate to this science community. I would say I'm coming from Munich, where the motto was we are among friends for navigation. Now I think that we are among friends for astrophysics and this domain, interesting domain. So the idea was, of course, to give a small contribution, just food for thinking for the prospect for the future activity on the moon Farside. We, since Telespazio is prime contractor of this Moonlight initiative with ESA, and we are also active with NASA for what concerns the LunaNet framework. Of course, one point of attention was also identifying some specific scenario, not only on the South Pole, that is main focus of the Moonlight and LunaNet, but also in other sites that for which there is a strong sense interest, like on the moon Farside. So we took under consideration these use cases that indeed was already considered by ESA in the second work of the Moonlight. One of the use cases was referring, generally speaking, to the astrophysics activity, and in particular we have been hit by this very brilliant project from Jack Barnes, where in fact there was also a very nice study conducted by ESA, a CDF study, so a concurrent design facility study, that has been concentrated also on this HALO, Astrophysics Lunar Observatory. So, if I may, after this introduction, we'll just review the main science requirement that motivated the technical requirements for the infrastructure. And around the tech infrastructure, we figure out a possible scenario that potentially could be applicable, but your feedback will be precious also to evaluate for possible collaboration in the future. Take into account the difficulty that you can teach me about the 21st centimeter cosmology, and in particular, as we will see, the reason why Jack Barnes has also motivated a solid, let me say, design for this astrophysics lunar observatory, for which, of course, the challenges are quite a lot, but require, on the same time, relevant communication and navigation facility in place in order to make a success this initiative. So, ground-based interferometer experiment, astrophysics lunar observatory design, lunar user segment scenario and services. Here we come as Telespazio as a service and large mission integrated company. Lunar High Accuracy PNT service, so I will concentrate just a scenario, a console of operation specifically devoted for positioning, navigation, and timing, not in this case considering the challenge for the communication. So we know very well, you know very well, better than me, this 21st centimeter cosmology. This very nice, I would say, hard beast of 21st centimeter cosmology. To be taken, the signature is very difficult. The relevant interest in this period of time after more or less 400,000 years after the Big Bang. So this strange spin flip transition that is the focus of this research, where, as you already mentioned in the previous speech, of course, as observed during the expansion of the universe, this sort of redshifting of this signature that introduce more and more, let me say, challenge and difficulty in identifying this signature itself. So in the bottom panel, in a way, we can also consider what will be the subject of the next picture, or the next slide. That is a sort of break-even that after this expansion becomes more and more difficult to use a ground-based infrastructure and then start to be relevant the need to have a space-based infrastructure for the HALO. This motivates this kind of research, and in particular during this expansion with this redshift we started to consider the need to not only to capture this 1420 megahertz signature, but also lower bandwidth, lower frequency in the spectrum. So we know that some infrastructure, some attempting to, with big effort, big investment, like SKA that is under development in Australia, is quite huge project, but also other projects like this that again try to capture this 21st centimeter cosmology. But which are the challenges that indeed there is a big challenge in this project, but at the same time, and also a big hope to exploit this infrastructure to capture this signature. But at the same time, we are aware about the challenge that are behind this. The aspect related to the radio frequency interference on the ground, especially for the low frequency signature, the aspect related to the ionosphere impairment that introduce this kind of absorption and scintillation effect, and multiple scattering effect that destroy this kind of possible, let me say, achievement and identification. And on the other hand, finally, there is also the primary beam stability issue that does not confirm the possible harmonization and calibration of all the dipole and all the relevant antenna to detect the same effect. So these motivated also on the other side from low frequency also other effects, other problems related also to the solar activity that start to, and the plasma noise, that start to more and more convince the science requirement, scientists, to choose a specific area which was perfect from this point of view, protecting and from all these disturbance interference, including also the solar effect. So deciding on the far side, the best place to choose. In particular, the Jack Barn study identify a specific, let me say, attention on a specific crater, a big crater, where there is a sort of radio quiet environment with a natural, let me say, insulation, even more than 80 dB, which is like equivalent of a nulling for a NATO jamming, is naturally protect also this region from very low frequency in the range of 100 kilohertz and beyond. And this was exactly in the so-said Tsiolkovsk crater the best place to choose for this project. This project, indeed, also called with this acrostics Farside, where the key science requirement was motivating a sort of distribution of 128 twice dipole antenna distributed with a spacing of about 5 meters, depending from the physics and geometry of those dipoles, in a large area, enabling the capturing not only of the frequency of the initial frequency of 1420, but also lower frequency due to the redshift. And this big infrastructure, of course, require a big effort in the deployment, and also the installation and maintenance, if you want. And the project consider, for example, a possible option for Blue Origin with this nice mission that is one of the Eclipse mission from Artemis, that envisage a central lander that you can see on the bottom left, enabling also the communication deployment of 4 rovers. Those 4 rovers has all the capability with the small mass to have the possibility to deploy these dipoles, and enabling with the precise positioning the delivery of these dipoles with the spacing, and at the same time with a very clever, let me say, concept. There is a flat conductor which allow to provide communication via a sort of distributed sound network, DSN, which exploit this flat cable connecting the rovers very simple rovers with respect to the mother lander. The mother lander enabling communication that in the baseline of the project was supposed to be toward the lunar gateway of the LobGib, if you want, having also capability in the baseline was initially KU band, but discussions are ongoing. There is also some possible project that enable also optical communication due to the huge amount of data that are in the range of 64 gigabytes per hour to be delivered within a cycle of 24 hours Earth day. But on the other hand, there is also this mechanism on the rover, on the 4 rovers, that allow to implement the geometry of this lunar observatory with this fancy approach of so-called zigzag, let me say, deployment, with some specific numbers that respect the geometry of this astrophysics observatory. So this design essentially provides and supports the idea to capture in all the possible flavor the 21st centimeter, let me say, signature in different frequency with this huge infrastructure. In the small video that here, we can see also the concept that is based on the Farside project, supposing to have a blue origin lander, and deploying, as I said before, this flat cable that indeed connect all the dipole and is enabling also the communication and telemetry among all the dipoles and among also the rover themselves. So the mission includes, as I said, this lander in Eclipse mission and these 4 rovers. There is a willingness to have, during the lunar transfer for what concerns the lander, of course, all the landing supporting navigation services, enabling at given before the braking phase at around 13 kilometers, a 3 sigma, say, precision accuracy, relevant precision accuracy, to be integrated with the onboard sensor, but also velocity in the range of 0.1 meter per second in 3 sigma, and also have a ground segment support in order to support the overall mission. For what concerns the rovers, there are other challenges that require at least a position of the base station in the range of 1 meter. But for what concerns the rover, is also required centimeter level accuracy, especially during the deployment of the dipole. For each dipole, there is a sort of waypoint that the rover needs to send some telemetry to the lander and the lander toward the lunar gateway or directly to Earth. So in this mission, we start to consider, starting from this space, a science requirement, the possible option to supporting the ongoing activity for lunar communication navigation. Several are in parallel ongoing. The one from NASA about lunar communication and relay navigation system. The lunar constellation from Moonlight, from ESA, and the lunar gateway that as an outpost, like the ISS, would enable several different experiments, but also an outpost for all the different Artemis, let me say, Artemis venture that will envisage robotic and also human exploration around and over the moon. So this is just the highlights of a potential lunar communication navigation constellation around the moon, where we have LCNS, Lunar Communication Navigation System Orbiter, both of communication services and navigation services. And the key benefits, of course, are that you can enable the communication navigation independently from the direct-to-earth connectivity, which is the case, which is not, of course, the case of the Farside, and at the same time having a good visibility toward the lunar gateway, which is in another orbit. We are talking about alpha orbit, very stable orbit, even though affected by three-body effect, and with a more stable configuration provided on the NRHO, in the orbit NRHO from the lunar gateway. So in this project we will, of course, we have started already for Artemis to support Artemis project since Orion, where from Fucino, where there is one of the biggest teleports in Europe, is managed by Telespazio. In S-band, we follow all the tracking for the Orion, supporting NASA for that. And we will do, for sure, also for the next future Orion mission. At the same time, within the Space Alliance, with the colleagues of Thales Alenia Space, for which we are in Space Alliance, there are development ongoing for what concerns main pieces, elements for the lunar gateway that are Italian flagship. We also have a facility in Matera, which is essentially used today for the selenodetic sampling of the moon with a optical telescope sampling the mirror left by Apollo missions. And we participate in this case to the IDST geodetic network worldwide. We will use also this capability also for lunar ranging for navigation purposes and calibration for the navigation satellite. In the meanwhile, as prime contractor, this disruptive project, we participated with a large consortium in Europe in order to define the first design, the mission design of the orbital configuration. And now we are bridging to the phase B2E, together with Thales Alenia Space, but also the colleague of SSTL, that should be in the room, from UK, from the support. The main support, as you know, are from Italian Space Agency and UK Space Agency. Of course, we are open to discuss potential future use case scenario, especially the science scenario, that are fundamental, especially from the fact that Moonlight is a private-public partnership, so indeed ESA is a partner for this enterprise, an anchor partner to provide the first service in the first 5 years. So, which could be, according to the global exploration roadmap, the next step in a perspective not only of a science age for the lunar, let me say, exploration, but also for the lunar economy, so for a sort of a commercialization of this exploitation. For sure, we will have landing ascending element as user, as potential user for the communication navigation, where the specific emphasis is on high accuracy navigation services that indeed are, like in the Blue Origin, becomes a sort of augmentation of existing navigation capability with sensor fusion that are indeed already present normally in the design of a lander. But we have seen also during these recent let me say, commercial opportunity, how difficult is to land on the moon if we don't have solid basis and enough money to fund such a kind of development. But on the other hand, we have also rover configuration, like in Farside project, where a specific emphasis are on navigation, of course, again, to improve the navigation in terms of visual odometry and wheel odometry and LiDAR and so on, but also provide services in terms of critical data and communication continuity, mobility, and so on. We have also in situ resource utilization to provide, to extract water, for example, from regolith, to potentially provide all the implant resources, equipment for habitat, for a future habitation of the moon. And finally, we will have over-the-top services also for science exploration with small orbiter that could be also nanosite, in principle, microsat. And finally, we envisage also a lunar high accuracy PNT service for an infrastructure like HALO. How could look like? So supposing, as I said, to have in the center this lander, which is a key hub for communication and navigation, also for the rovers that go for installation, maintenance, and repair wherever is possible for the infrastructure. We have the 4 rovers, where we suppose to have also some range signal, opportunity signal, to augment the capability for the navigation, precise navigation at centimeter level. So in order to provide this, and to cope with this expected navigation KPI, so sub-meter accuracy, indeed for specific phases, as I said, for deployment, centimeter level accuracy, for sure we will use such a kind of range for the navigation constellation, like from Moonlight, but not only. But this will be, in order to reach this centimeter level, from the signal in space error that are provided only with 4 satellites, is not enough if you compare with navigation satellites, constellation like Galileo or GPS, where there are more than 24 satellites to provide the geometry. Then, for sure, you have to consider a sensor fusion on board, where you should, in a Kalman filter, integrate all the observable available on board, observable with visual odometry, but also wheel odometry, but also the pseudo range attained by the constellation. Supposing that the constellation is able, even though designed to specifically provide the better performances of navigation and communication on the South Pole, anyhow, due to the typology of orbits, the eccentricity, and also the inclination, we realized that such a kind of orbiter can for sure cover, as you can see, more than 20 degrees in latitude. That is supposed location for Tsiolkovsky crater. So supposing this, and supposing, as I said, to integrate a lunar position navigation terminal, user terminal, with a small size, weight, and power, integrated in this very small rover, we can integrate on the same equipment all the observable, as I said before, including, I can guess, also the flat cable that potentially in the sound microwave could provide also ranging capability toward the lander. So a sort of tether deployed along all the infrastructure. So this concludes my presentation. I don't know if you have questions.
Thank you. Dave DeBoer, University of California, Berkeley. What are the effects of the regolith on these short dipoles that you're going to deploy right along the surface? Has that been studied?
Yeah, was the same question that I placed to a colleague of NASA, where still they are studying the effect of the regolith, especially from the mechanics and, but not only, also for EVA, that are very aggressive in terms of. For sure, what is important that is at least in this architecture is the impressive simplified architecture of the rover. This is very important because the rover will be the most critical asset that will be employed 24/7 for the deployment, but also for the monitoring of the aging of this infrastructure. And the capability also to have this flat tether, which indeed using this waveguide with sound is not affected with any kind of RF equipment where we have, of course, mechanisms to move. You can have problems with regolith and so on. A criticality is for sure for the lander, so the Blue Origin lander, where it's supposed to have a lot of infrastructure to provide such a kind of communication throughput, 64 gigabytes per hour to be deployed. So you need optical links, and for sure the effect of the regolith has a relevant impact. So some discussion are ongoing. We know very well from NASA, and this is that will be the next challenge.
And I assume the electromagnetics of the dipoles themselves are being studied as well, I'm sure, but I would assume that would have quite a large effect.
Yeah.
Thanks a lot for the talk. If you allow me an astronomical question, the foreground, the galactic foreground, should or will probably play a big role in this experiment. Are there already studies of how to subtract this and whether you can actually effectively remove it in order to get to the cosmic signal?
As I said before, thank you for the question. As Telespazio, we are concentrating on the service, so the communication navigation, not. We followed in this presentation the science requirement and the motivation for the infrastructure to be, as a critical infrastructure, to be monitored and to be supported for the navigation, let me say, intervention. Of course, we are not in this matter of the science design that comes from, as you know, from Jacques Barne.
Other questions? Okay, so let us thank again Dr.
Thank you.
And let me introduce the next speaker, Dr. Franco Fenoglio. He is a manager of human and robotic planetary exploration programs at Thales Alenia Space Italia. And I think we don't have the presentation. Okay, può mettere qua. Grazie, Luca. The title of this presentation is Thales Alenia Space, Artemis and the New Moon Ecosystem.
Allora no, vado sul ultra USB. Però si accende.
Good afternoon to everyone. Thank you for the invitation. And we are going to see a sort of overview of what we are doing in the frame of the overall Artemis adventure. And you will see the part that we are already working on, and we are doing both in terms of design and in terms of hardware, because we are actually already on the way. So just to remind which is the main difference that the Artemis program is representing with respect to what we have done already on the moon. This is a program which is an international program, and in fact for the module where we are involved, you will see that there is contribution from several agencies. NASA is leading the effort, but it's let's say a sort of international effort. And the other point that makes some difference is the fact that there is the involvement of private companies now, in particular for the lander. I think every one of you knows that SpaceX and Blue Origin gained the contract for the landers that will bring human to the moon. But the main difference, this will no longer be a one-shot, I would say, mission. It will be a sort of a program to allow to establish a long-term and sustainable project for building up really the human colonization, I would say, in the future for the moon. More or less, there are two main phases. The phase one is the one on the short term, basically within this decade, to bring back humans to the moon. And starting the gateway, which will be the outpost where we can remotely control and where we can start a source mission to the moon. The phase two, from the end of the decade next, will be basically the gateway completion and to ensure a sustainable presence on the moon with progressive, I would say, infrastructure and asset to be placed there. We are talking about Artemis, but if you rely on what NASA is doing, basically Artemis is already in the frame of, I would say, even a larger program, which is now Moon to Mars, M2M. So these to remind that whatever we do on the moon, in principle, is also aiming to, let's say, define and try to start to characterize things that could be useful to go and to make the long jump to Mars, of course, with the difference that will occur. On the right, you see which are the key elements of the Artemis: the launcher, the Orion capsule, the gateway, the landing system, and the base camp with all the assets. So we will see briefly, particularly what we are doing on each of these. Let's start from the short term. Artemis had the first successful mission last year with a flyby around the moon and crew, a mission of 26 days, and it will be followed by Artemis 2 in 2025, which will more or less do the same kind of mission. I think the duration will be 10 days, so again a flyby to the moon, but with the crew, 4 crew. Artemis 3 is the key point in 2026 to bring humans to the moon, and the first time there will be a rendezvous of the Orion in lunar orbit with HLS. 2 of the crew of Orion will move to the HLS and they will go to the moon. After that mission, in principle, what they think is that the lander will go to the gateway, the crew will be there, they will pass to the lander, and they will start to make the mission to the moon itself. We have been involved on Orion on the service module, which is provided by Europe since the very beginning. You see the picture. We are doing a significant part of the system, because we are providing basically all the thermomechanical system, structure, micrometeoroid protection, the thermal control, which is pretty complicated because it's an active loop, dual loop with something like 20 square meter of radiators, and all the system for the consumables, storage and delivery. That means nitrogen, oxygen and water for the crew. Where we will go with Orion? We will go to the gateway. The gateway, just to be clear, the main difference, by simplicity we call it the lunar station, but there is a big difference with respect to the International Space Station, apart from the size, because the gateway is definitely smaller. But the main point is that if the ISS is permanently inhabited, the gateway will be visited, basically once per year, for a mission of 30 days by a crew of 4 that will be brought there by the Orion. And so it works more as a sort of outpost. There will be research, there will be experiment, but it will be used also to remotely control, for instance, the next operation on the surface. You see there that, as I mentioned, the permanence is around 30 days for 2 reasons: to diminish the logistic and to avoid a too long exposure to the cosmic radiation. It will support lunar exploration for the surface, continuous view to the Earth, and it will be, for the first time, we will be outside of the magnetic field of the Earth for a permanent station. So it will be used also as a test bench for radiation and other type of experiment. We can say that we are really at the backbone of the overall gateway infrastructure. Apart from the power and propulsion element, which is provided by US, you see that in this moment, in all the other modules, we have a strong involvement. HALO will be the first module planned to be launched in 2026, and there is provided by Northrop Grumman, and in continuity with what we are doing for the Cygnus cargo provision, we will provide the structure and the mechanical system. Whereas for the other 2 modules that you see here, that are Esprit and IAB, IAB will be the actual living core of the international gateway. It's called international because it's provided by ESA to NASA, but with contribution by JAXA, that will provide, for instance, the environmental control, the Canadians for the robotic interfaces, and NASA for some crew item. Esprit is basically 2 parts. There is a first kit that will be launched with HALO, and is what is called HLCS, HALO Lunar Communication System. Is a kit which is a sort of backup of what is already in the power and propulsion module to allow the communication to the moon surface and with the other element of the gateway. The other part, which is actually, this part is for the refueling, to bring fuel, storage fuel for, in particular, PPE. This part, which is the part we do in Torino, is a pressurized tunnel for cargo, and you see that it will include windows, so we can consider a bit the cupola of the gateway itself. And here, just to, let's say, to give some proof that we are much more advanced than simply doing study or design. You see, this is HALO. On our stand, HALO is basically ready. We will have to deliver to Northrop Grumman at the beginning of next year. On IAB, we are starting to build, to procure part, but the first part we did is this mock-up. It's a low-fidelity mock-up, because one of the problems that we have for this module is that the size is reduced with respect to what we have in the space station due to launch mass constraint. And so one of the key problems is to prove and to test the habitability within the module, which is, I would say, a bit constrained. So this will be used, I think in May, June, we have a campaign of a human-in-the-loop test with the participation of NASA and this astronaut. Will be the first one of a long series of steps. Let's move to the surface. So the surface, we are pretty active with our Italian Space Agency. These are two programs that we did in 2021. The first one was for a set of feasibility work on lunar asset, and we dealt with several topics. I will not list all the 16 topics, but you see that we went from modules to problem of electrical power generation, etc. And this was in parallel with MPM, that stands for multipurpose module, that was basically started to design the module, or the crew module, the structure of the crew module for one of the competitor of the HLS, the Human Landing System, that unfortunately was not the one selected. But I think the important things from our side is that we did in parallel a set of pre-development on transversal building block that will be anyhow present in whichever module we do on the lunar surface. So in particular the windows and all the hatches and the mechanism for the EVA door and other stuff like that. And this is what we are working in this moment. I'm just coming out from a meeting, a face-to-face meeting with ASI and NASA that we had this week in our premises all the week long. This could be the candidate for a bilateral between our Italian Space Agency and NASA, and potentially it could be the first actual permanent habitable module on the lunar surface. It should come just after the lunar terrain vehicle and the pressurized rover, more or less. We are talking about the beginning of the next decade. It will be, at the beginning, a sort of outpost for the crew that will move around with the rover, and we have to equip with an airlock to allow EVA in and out. We will have to be fully autonomous. That means we will need to generate our power, and we will have to be capable of interoperability with other assets. The idea to proceed with a sort of building blocks, it's to give us some modularity and flexibility to the module to grow up. The challenges are several. You see in the chart, I just listed some of the main one, the mass and the volume, the interfaces with the other asset. One of the problems will be the survival of the lunar night that requires a lot of energy to be stored and some mass of the associated batteries. I think it was already mentioned by Shura in some of the previous interventions that one of the problems on the moon surface is the lunar dust that we will have to understand how to prevent. We will have to understand how to offload the module from the lander and position where to position. Also the site are under investigation, but we will be around the area of the South Pole. And the other key point that is under discussion is the mobility. The mobility could be short range or long range, depending on also safety aspect. By sure, we will need to move far from the lander, even because when the lander will ascend. At that point, there will be the problem of the potential plume impingement and the dust, which could, let's say, create problem to all the asset. But I would say that this is at the beginning, but this is probably in the next years, it could become one of the major programs we could have, and it's part really of what is the overall Artemis architecture for the surface. So NASA is assessing with us this with the idea to introduce at a certain point in the global architecture, which is, I would say, basically in a sort of continuous evolution. And just to complete the picture of what we are doing on the moon, on Moonlight, I think that was already touched before, so we are involved with Telespazio as a prime to support this commercial and institutional mission around the moon with positioning and simplification. We are basically taking in charge more the part of the navigation. The EL3 or Argonaut, it's something, in this moment, it's a proposal we are having competition, but it's an ESA initiative to try to create a European autonomous access to the moon for a series of missions with several payloads. The target is to bring at least 2 metric tons of cargo and keep the launch on Ariane 6, because as I said, it's a part of a European adventure. And to complete the overview, we have also studying several other aspects. Here we are in terms of advanced project, both for the locomotion, the rover system. You see there are studies about the power station. One which are launching now is something in the frame of the Italian PNRR, which is this LAOR system that I have to read the acronym because it's too long, but anyhow, is to provide an infrastructure to be capable to host scientific instrument for scientific experimentation on the moon. We will do with Altec for the ground segment, and the objective is also in this case to understand whether between the MPH, for instance, or other asset, we can support an adequate infrastructure for, let's say, for allowing this experiment to properly be activated and utilized. And so I think the overview was pretty quick, but just to conclude, what I can say is that what we are experiencing in the latest time is that really the approach to this kind of program is changing with respect to what we were used to doing, for instance, at the time of the ISS, where we contribute, I think, for 30–40% of the pressurized part. Because I would say we are really talking about a sort of ecosystem in which several pieces of architecture have to talk to each other. Of course, we have our core business, which is for the pressurized module, but I think that the approach is changing also in how you have to manage the program. For instance, in particular with the subcontractor or supplier, we cannot follow the standard, the usual V-cycle with the serialization, specification, etc. We really need to talk with them since the very beginning, trying to exploit what can be already available, because in order to be sustainable, you must be sure that also the costs are contained, and that most of all, that you have a clear path to to develop the technologies right in time for when you will have to use it, because otherwise, I mean, it would be really challenging to, let's say, to satisfy all the demand. And with this, I thank you for.
I have an idle curiosity question. An impulsive solar flare from the sun without the protection of the Earth's magnetic field delivers a lethal dose of radiation to humans in something like an Apollo capsule.
Yes.
And I think they realized after the fact that all the Apollo missions were simply lucky in not having encountered those, because they're very frequent during solar maximum, and even during solar minimum, they don't stop. They still have a frequency that's slightly higher than the durations that you're talking about. So can you tell us a little bit about the storm shelters that might be planned?
For the radiation, I mean, it's clear it's one of the key aspects. What I can tell you is that we can probably manage for short duration, as I said, on the gateway. One of the reasons for limit to 30 days, it's logistic, but it's also, I would say, to avoid exposure to radiation, and we have to distinguish, I think, because for the solar particle events, maybe we can protect, I would say, if the duration is not too long with the type of module we have now, because it's clear that it's pretty useless to increase the thickness of the metallic shell. I mean, we would just increase mass without taking some benefit on the radiation. But for instance, in the crew quarter, which is the part where they will spend maybe 8 hours for the rest period, one of the solutions we are thinking is, for instance, to put on the back of the shelter layers of water. So we have a bag in which we can put water. Water, of course, it's one of the right, let's say, material to protect from the radiation. If you talk about the galactic cosmic ray, I think that as of today, we don't have yet a full technology developed. There was a study in the past, I remember, because I followed the one with ESA, in which the idea was to try to, I would say, build up a sort of magnetic field with an infrastructure rotating that was simulating a sort of. But when we, I would say, assess which could have been the mass of that infrastructure, was something like 12 tons or something like that. So it's not feasible, because otherwise you will not launch. So I can say that for the cosmic radiation, for the SPE, in this moment, if we do not exceed too much the duration, we can start, let's say. The day in which, for instance, we will have to go to Mars, I think that if we will not be capable to really find a technique or a technological solution for the common galactic, we will not be able to expose the crew to 8 months of travel for that. So it's really one of the key aspects that we have to face in particular for the mission to the deep space. For short sortie mission on the lunar surface, I think that we can survive, and by sure we can improve by studying also the internal layout, you know, to put layers which are not metallic, but there are parts which are in polymeric or other that can make some shield. But for the longer mission, you are right, we will have to face and try to find what we can do.
You have the same protection for solar gamma rays and solar energetic particles?
No, as I said, for the SPE, in this moment, we can rely a bit more on the layout. They are, at least from what my specialists say they are a bit more predictable. So the concept is to build up a sort of area which is called a sort of safe haven. Orion, the capsule, has been built to be a safe haven for this case. For the cosmic galactic rate, you are right. I mean, this is not enough, so we will have to study what to do. Yeah, gamma rays, sorry. Yeah.
Thank you. Can I just follow up this point, because I think it's pretty important. The water protection, is that going to be implemented on your landed surface habitat, or the gateway, or both? Because as things stand, it looks like your surface habitat doesn't have much radiation protection.
No, for the moment being, not yet. But again, we are talking about 7 days in this moment. By sure, in the moment in which we will have to go to extend the duration, and in particular when we will have to, let's say, think to have a permanent and longer duration, we will have to understand what to do. There are several, let's say, hypotheses that are being traded off, like to use a regolith by in situ reserves to build up a sort of a shield. There are people that are talking to, for instance, locate this module in the lava tubes. It's clear that we will have to balance all of this, because if you put in the lava tubes, at that point you have the problem how you get energy for the solar array. So it's when I was saying, of course, going to the moon is opening a set of, I would say, investigation that is much more complex than what we did, for instance, in the ISS. In the ISS, I think we learn how to live in space, but in a space which is protected by the magnetic field. Now that we are going out, by sure, and I think that we are starting to understand what to do, by sure, the reason for keeping the duration short at the beginning is induced also by this matter of the irradiation, even if it is not the only aspect, to be honest, because there is a problem also of logistics. If you increase the duration, you need much more logistic. And I think, again, if you want to be sustainable on the moon one day, you will have to implement ISRU, because you cannot think to go on continuously with the launches from ground that I would say are costly. And the day that we will go to Mars, it's even different, because in that case we will need to be autonomous.
So in the short term, is it true to say that we'll have to rely on the space weather predictions, or the solar predictions for solar flares? Because otherwise, as
could
Richard,
be, yes.
Richard said,
I'm not an expert of space weather, but it could, yes.
I mean, otherwise we're gambling.
Yes.
Right. So 7 days may minimise the
But-
risk, but you're gambling between.
Yes. No, I think it's a bit what we experience, for instance, on the space station. On the space station, for the micrometeor and debris, for instance, it was not the same, the protection that we applied to each module, because it was depending on asset, etc. So, of course, we had to do simulation that were considering also the model, what way they were predicting of the possibility of impact, depending on the attitude where the module were. So.
Very different topic. Thales Alenia is also involved in building modules for the Axiom space station, I believe.
Yes.
And so, but doing so at much lower cost than for the ISS. And I was wondering, but also hoping, that some of those lessons could be applied to the lunar case, and you would be able to do it much cheaper than you were able to do the original ISS modules.
Yes, even if to the lunar you change the environment. So, I mean, by sure to go to the moon, it's not so cheaper with respect to the ISS. But if I have understood correctly your point, what I can tell you is that for the module we are building for Moon, by sure we are leveraging what we did for the ISS. At the same time, mixing with what we know will be needed in terms of innovation, in particular material. We will exploit, for instance, the fact that on the lunar environment, at least in this moment, we have the micrometeoroid, but we don't have the debris as we have in the ISS, so we can save something on the micrometeoroid protection. There are things that we develop for the ISS, but by sure we can use, I wouldn't say a fully recurrent item, but it's an adaptation of what we have done. So if I have to give you my personal impression, the structure is always on the critical path of the schedule, but because it's coming before. But I'm not afraid of or I'm not concerned on the structure. I'm more concerned on the point we were discussing before, and also on the equipment, for instance, that will have to ensure the functionality, because on that there is all the problem of the derating for the environment, the radiation, etc. For the structure, you're right, by sure we will use some benefit in terms of the schedule also, rather than on cost for building the best that we can, I would say. Thank you.
Okay, ladies and gentlemen, it's basically 4 p.m. We are sharp on time, typical for Italian tradition. So now we have a break, let's say half-hour break, and then we can gather here again for the last talk. Then we will have the award ceremony for the art contest that you can see here around the room, and the final round table. So see you in a half hour. Thanks.
magari era stata fondata una combricola e poi dopo, quello ufficiale, avevamo anche 500 anni, erano stati celebrati, tutto che è rosso, adesso non mi sono preso gli occhiali, sono andata a vedere una locandina, perché quando...
Beh, comunque io sono uscito dall'università nel 2003.
Lei ha una cosa?
Fisica. Ma io avevo anche il professor, insegnava Garfagnini. Anche se avevo sostenuto una tesi sperimentale fuori all'Istituto di Metodologia No, insegnava ancora. È sempre stato molto chiaro, certo, probabilmente. Io avevo poi tenuto anzi, lei non aveva assistito, però se non sbaglio era ancora direttivo infatti mi aveva dato il permesso di tenerlo, era sulla lente gravitazionale del Sole e avevo tenuto questo seminario dell'osservatorio. Lui però insegnava meccanica, non insegnava laboratorio. Ok, chiedo scusa. Oh, sorry. What time is it? Yeah, time to restart. So, our next presenter is Dr. Charles Cranston. I hope. Okay, good. No, I was more afraid about the pronunciation of your last name. And he's a project manager for Lunar Pathfinder at SSTL, Surrey Satellite Technology Ltd. And his talk has the title Responsible Steps to Opening Up the Lunar Economy. Stage is yours.
Cheers, thank you very much. Charles Cranston, as I've been introduced, not a doctor, but thank you for that additional epithet. First of all, thank you very much for hosting us here. This has been fantastic. I have to say, first time I've been to Turin, and it's very, very nice, especially the food. If you haven't been to Italy just up the road, I'd strongly recommend it for lunch or dinner. It was delicious. So today I'll be talking about the responsible steps to open up the lunar economy. I've been the project manager for Lunar Pathfinder at SSTL for the last 5 and a bit years. I started off at the study stage for it, and we've taken it through, and we're currently in build at the moment. So the emerging lunar economy. PwC have forecasted the market over the next 15 years will accumulate up to $170 billion. The NSR, the moon economy, is set to generate over 100 billion of revenues from 21 to 2033. And the Euroconsult, overall annual government investment towards space exploration has been increasing and is 59% higher than 10 years ago, and that was by 2022. So by 2031, it's forecast to reach $31 billion. So the lunar economy is well on its way. There's a lot of investment in this area, and we're hoping to act as an enabler for these key technologies to be used, and all the science missions have been talked about over the last 2 days. So as part of our study phase, we went through a market analysis and we looked at the number of missions that were going to be occurring over the next few decades. As you can see, there's a slow increase in the number of missions in the immediate time frame as the cadence starts to build. Then we get a stable flow of land emissions. This is primarily building on the back of the ECLIPSE program from NASA. And then from the 2030s onwards, we start to see a steady presence on the moon as we start to get things like Gateway and the long-term human habitation on the surface as well. This correlates quite nicely to the amount of data. So you see in the initial time frame a small amount of data on the daily data volume anticipated, but then there's a significant ramp up from about 2030 onwards being forecast as a steady presence and those missions start to take a stable flow. Just another graph to show the high data throughput as it increases. So in order to get this data back, especially if you're working either at the South Pole or on the far side, generally direct to Earth link comms is quite difficult. So you do need a data relay. So a couple of reasons why data relays are becoming more and more important. Availability. At the moment, the direct to Earth capacity is becoming limited with the requests for the direct to Earth starting to outnumber the bandwidth that is available. So you're starting to see these are routinely oversubscribed as the demand is growing on these. In addition, as mentioned, if you're going to the far side, line of sight becomes a real problem. You don't have that direct to Earth capability. So you have to be putting in those relays, as we've seen from the Chinese putting those in place. At the South Pole as well, you have topology problems where if you're in a crater that's permanently shadowed, you have no access with direct line of sight back to the Earth. When you're doing landings as well, flexibility on the amount of data you need and the access, the requirements are changing very, very frequently. During the transit stage, minimal data required, backhaul, but when you're doing the landing phases and lowering orbits, suddenly you need a high bandwidth of data transmission. In addition, science versus cost. So if you don't have to take a big, heavy direct-to-Earth, power-intensive piece of equipment, you can replace that with scientific payloads. You can take lighter comms, user terminals to communicate with a relay satellite that can get the data back for you, thereby getting more bang for your buck on the science generated per currency. So SSTL has been developing Lunar Pathfinder. It's about 350 kilos, the size of a large industrial washing machine. It has X-band Earthlink comms, and then for the Moonlink side, we have S-band high-gain antenna, that's the dish, and then we have a wide-beam S-band antenna as well. We're not just doing comms, we are taking a number of research payloads as well. These are our hosted payloads. We have a laser retroreflector, GNSS weak signal detection, and a radiation monitor to gather data while we're in that environment. When the laser retroreflector and the GNSS weak signal detection measurements are coupled with our own radio ranging, we get 3 points of accuracy for navigation technologies, starting to pave the way for future constellations and technologies that could be employed by the likes of the Moonlight constellation. As for the service offering that we're looking to implement, we would be supporting pre-launch services, so aiding missions in developing their mission requirements, supporting the implementations of their comm systems, making sure they're compatible with our Earthlink, with our Lunar Link systems, and ensuring that they can tie into our Earthlink comm stations as well. Throughout this, we can provide the expected performance estimates as well during that early stage. This is all part of the onboarding and development side of the offering that we have. We then have a number of baseline services. We have the autonomous service, which is when there's no requirement to get data back at a certain point. You can generate the data, and then we will get that data back when it fits in with the overall planning schedule. This is by far the most cost-effective way, as we're not having to constrain when we have to do ground station contacts. We then have the scheduled service, which is more defined by when the customer needs data. This is going to be more important for missions that have mission-critical phases, such as landings or rover operations, for example. And this takes priority over that autonomous planning and would be the first that gets put in. In addition, we have an emergency service, which is to support missions that may be having trouble that need urgent comms put in place. So looking to make sure that we can provide that emergency support. And then in the future, we're looking to enhance Pathfinder through firmware updates at the highest level of performance, looking to get the lowest latency possible out of the system by automating a number of the on-ground processes. Pathfinder could also be used as a backup with regular hailing of the asset by Lunar Pathfinder, and potentially even doing asset data-to-data communications without having to come back via the Earth. As for our commercial model, SSTL Pathfinder is wholly owned and operated by our SSTL Lunar enterprise. We have ESA as an anchor customer, and we provide them with the services. They have procured those from us. This is a new way of working for ESA. Rather than procuring a satellite to own and operate, they are buying airtime, like you would with a mobile contract. With this data, they've then been through a barter agreement with NASA through a Memorandum of Understanding, an MOU, and in exchange for those data services, they are providing the launch opportunity through the CLIPS program, and we'll be launching at the back end of 2025 with Firefly. All this gives SSTL Lunar the ability to service ESA missions primarily, NASA missions as well, but also commercial missions globally. So we're not constrained by serving a single agency. So just to show you this is a real thing, on the left here we have our risk reduction model, which is the flight panels and the panels doing the soft deploy of the solar panels. Everything inside is a mass dummy. And then on the right, we have a time lapse of our S-band high gain antenna. This is a carbon fiber antenna with a swash plate mechanism that we've developed at SSTL. So, talking about the designs and making sure that we're a responsible supplier into this economy and this environment. From a design perspective, when we started this, we actually had UHF as a moonlink antenna. And the whole point of choosing this was we believed that from a market analysis in the initial term, we would have missions that would choose UHF, at least in the few years before it was then phased out in favor of S-band. But by the time we had retired Pathfinder, UHF would be essentially dead and buried because the shield is on the moon. But as we've seen, this is advancing a lot faster, and we've seen the community turn away from UHF, and we're now focusing purely on the S-band comms links for the Moonlink. And we have actually replaced our UHF antenna with this UHF wide beam horn down on the right. We've enacted requirements to limit the maximum permissible power densities of spurious emissions in the listed bands. And these are being fully flowed down to our suppliers and designers of radio transmitters and filters. And this is all verified via equipment level and spacecraft level testing. So primarily in the first instance, we've set a baseline to ensure the protection of the radio astronomy bands for our emissions. Regarding frequencies and emissions, we have conformance with the recommendation of the SFCG 322R5. That's the communication, positioning, navigation, timing, frequency allocation, and sharing in the lunar region. As you've got there, we've got our operating frequencies that we've submitted to the ITU and currently in review. And we've ensured that there are no emissions below 2 gigahertz. So we're compliant with the protection of frequencies for radio astronomical measurements in the shielded zone of the moon. For our operations, we're also ensuring conformance because we're going to be servicing missions on the surface and in orbit. And we're conforming with 22.22 to 22.25 of Article 1 of those radio regulations to ensure that we're protecting that shielded zone of the moon. We actually had a clarification question from Ofcom, the UK governing body for this regarding the shielded zone of the moon, how we were respecting this, to which we provided a full compliant response. Regarding service delivery, just to give you an overview of how we're operating, will be delivered as mentioned by Firefly to the lunar orbit. This is an elliptical frozen lunar orbit, otherwise known as an ELFO. And while we're in transit, any data will be delivered back to us by Firefly, and that will be delivered straight back to our operations center. Once we've been delivered to the lunar orbit and we begin operations, all our data will be backhauled to Earth via our X-band to KSAT's ground station network. Data from that network is then linked via API into our spacecraft operations center. That data then is managed and then shared back to customers via document sharing capabilities. So we're ensuring as part of our onboarding that they're fully linked into those. As part of this link as well, we offer encryption on the Earth link, but we are transparent to encryption on the whole link. So if a customer wishes to enact encryption for their data, Earth to Moon, we are transparent to that, and that can be fully implemented on the customer side. So the first mission that we'll be servicing is Lucy Night. We've heard a lot about this over the last few days, and we've been in close consultation with them to make sure that we are not going to act as a radio interference source for them on that first mission. As we know, many times as we said, we're looking for those weak signals from the universe's dark ages, and it'll be making observations in those ranges there. So we're providing that comm support. Lucy Night will be operational during the lunar night. We'll be gathering the data when they transmit via the user terminal. That's on the little tripod up there. That will be the primary means of communication back to Lunar Pathfinder, and then we'll provide that data back to the Lucy Night team. So there are a number of open challenges that we've noted. SFCG for Lunar Comms forbids the use of any radio transmissions towards the moon below 2 gigahertz. As we said, we are avoiding emissions below 2 gigahertz, but, and I'm quoting this from my ESA colleagues, I'm not an engineer on this, but no powered flux density is defined for the lunar surface to verify emissions masks for communication systems, and S-band might generate spurious elements. No mask is specified in SFCG to verify the emissions cleanliness, and the standard 60 dBc requirement for outer-band spurious emissions may not be enough to suffice for radio astronomy. Consideration of these at ESA, but requires community discussion and agreement. So happy to act as liaison for our ESA partner on this. If anyone has any thoughts about this, just pass me your details and I'll put you in touch. And then the future. So, Moonlight. Lunar Pathfinder will be the first node in the ESA Moonlight constellation, led by our colleagues at Telespazio. Services will build on Pathfinder's capabilities, providing the enhanced data rates, throughput, and additional band. That's meeting, if you remember back to that graph I showed, the high data throughput requirements. It'll be interoperable with international initiatives such as NASA's LunarNet and JAXA's LNSSS. And these infrastructure initiatives will be enablers for more ambitious astronomy missions, many of which have been talked about over the last 2 days. So Lunar Pathfinder is going to be launching at the back end of 2025, adhering to the shielded zone of the moon, enabling the key science through things like Lucy Night, and be the first node in Europe's Moonlight constellation. Thank you. Any questions? Any questions?
Yeah, thanks a lot for this talk and the very considerate approach towards radio astronomy services. With respect to the mask.
You're asking me a question well out of my wheelhouse, but go ahead, by all means.
Okay, then I probably should make this.
No, but feel free to, if you've got a question specifically around that, let's have a chat in the sidelines and I can pass you the details of my ESA colleague who passed this on.
Yeah, no, it's more a remark. I mean, the radio astronomy community would, of course, not interpret this much debatable. Of course, we haven't set any lower limits on the emissions, out of band emissions, in the frequency range that below 2 gigahertz, but we would consider this anyway a given mask, that there should be no emissions, by whatever this means. Maybe we will apply these the limits given by several recommendations on Earth, but maybe it's even more appropriate to even set different limits. But this is very important to be discussed, and thank you for the hint. Yes.
No problem. Any more questions? No, I think we're all good.
Yeah, we're all set.
Cheers. Thank you very much.
Sì, no, sì, penso di sì. Ah, no, non era collegato. Mi ricordi come fare a ritornare nella... Entra con l'audio del computer? No, vai. Sì. Okay. We've come to the end of the presentations, so thank you all. Dopo comunque. Now it's time for put science aside for a little time and talk about art. We've had some contestants that sent us their pictures. Some of them are connecting online. And we've asked you to vote your preferred piece of art. Now, just to mention them, starting from the corner at the end, your left, we have Martina Trovato with Join the Farside. Coming toward me, the next one is was sent by Camilla Casadei, and the title is B-Side. Here we have Camilla Bitossi Coronedi with Silence Required. On the other side, starting from the bottom, we have a group of artists, Chiara Comiotto, Ramona Fornito, and Giorgio Villani, or also known as Polyfox. And the title of their painting is Mooney. Coming towards us, there is a piece of art by Beatrice Raviola called A Cosmic Comedy, followed by Leonardo Rizzi, From Afar, and the last mention is by Miriam Minazzi, Un passo alla volta nell'universo, that is one step at a time in the universe. And the schools they are from, or the organizations they are from, are IAAD, or Scuola di Fumetto di Milano, or Accademia delle Belle Arti di Torino. You voted, and we have a winner. And, oops, that was not a piece of art, part of the contest. It's my touch screen. And we have a winner, and the winner is Camilla Bitossi Coronedi with Silence Required. Please approach the stage. Claudio, please come in. So, proceed. Vai al centro, così facciamo le foto vicino al pezzo. And congratulations to all the participants. They were very masterpieces. And congratulations to Camilla Bitossi Coronedi with Silence Required. That's an idea. Thank you also for joining online to Leonardo and Chiara Comiotto. Now, I hope those pieces of art were of inspiration for the next step, let's say the conclusion. And I would ask Claudio, which again, I would like to thank you very, very much for, well, giving the idea and organizing this, this symposium, the first IAA symposium on the moon Farside protection. He's going to give his final talk, and then we can start the round table. If you have any comment left, if you have any questions, if you have any discussion, you will be more than welcome to contribute to this round table. Presentazioni. Prego.
Well, let me just say that it's true, I had the idea of running this conference for the first time ever, but without the support of these three guys and related people, it would simply never have been possible. They did the whole work. I am also handicapped, so you see that I really had problems at age 76 to run a conference like this. Nevertheless, the enthusiasm is true, and so we made a start in protecting the far side of the moon that, in my opinion, was never made before, even at United Nations COP where I was recently. Okay, thank you very much. Please clap these four guys that helped me so much. So, I start again saying just a very few words about the United Nations COP. You see this room, half a circle in the parliamentary style. It's the place for all delegations of spacefaring countries and more, even if they don't have a space mission, it doesn't really matter. And this curved skyscraper is in Vienna, on the left bank of the Danube. The Austrians call that the United Nations City. And this is where the famous COP, Committee on the Peaceful Uses of Outer Space, is located. We met recently, about 1 month ago, that there were several other people, besides myself, for instance, Richard Green, representing the whole of the world astronomical community. That's not a small thing at all. 12,000 people, astronomers, whatever. So anyway, perhaps I was too ambitious. This is the presentation that I made there. But sometimes in your life you have to be ambitious. Otherwise you keep doing small things. But this is hopefully a revolutionary new thing. It will take 10 years, 20 years, who knows. But the conclusion is that I suggested to have, or to prepare, a Farside science treaty. Why treaty? Because that's the only way, in my opinion, to to get the support of all countries involved for a way or another to the moon Farside protection, you know. So this is what I suggested, and essentially we would like to write down a list of either accepted or forbidden frequencies for their spacecraft when they fly above the Farside. This is once again an ambitious project. We plan to submit this draft proposal to the United Nations COPUOS in June, because in June it will be the last session in this year. If we fail to do that, even in a very rough draft copy, then we have to go until February next year. So we are losing 6 more months. Now, of course, the problem about all this is that negotiations are urgent, but they are also legally uncertain. So this is why I need the strong support from the legal people to cope with this aspect, you know. The unique importance of the Farside has been presented already. The shielded zone of the moon was proposed by ITU as early as 1974. I'm not going to repeat what was said earlier today, but the crucial point, in my opinion, is that there is a basic difference between the situation around the Earth and the situation around the moon nowadays. Around the Earth, we are in a serious situation, in my opinion, because, as we all know, there are a number of space debris objects orbiting the Earth. It's not easily invisible that they will collapse on the surface or burn out in the atmosphere. So this is a real serious situation, and they are hampering astronomical observation from the ground. As we all know, the astronomers, of course, are aware of this. Around the moon, the situation is different. There is still much silence. I'm talking about, of course, radio silence. And essentially, there is only one space mission so far that reached the far side of the moon, the China mission Chang'e 4, with the relay satellite Keqiao. And so the frequencies are not many. And this is why we must take advantage of this situation. We must not waste time hoping for the best. We must do action. So the negotiations are urgent among scientists and space politicians. Let me please remind you once more, I did it already, but forgive me, 4 areas of science that could be done better on the far side of the moon than on Earth today. And going quickly, the first area is, of course, cosmology. We heard many experts telling us about that, the dark ages and all that. Another area is, of course, astrobiology. Ian was telling us about that from Birkbeck College. The next point is, of course, SETI. Come on, we have been doing SETI for 50 years from Earth, and now it's time to try to do it from the far side of the moon. That doesn't mean at all that we will ever discover extraterrestrial, but at least we must try. To these 3 applications of radio astronomy from the far side, I personally try to add planetary defense. In my opinion, planetary defense might be the extra contribution that would force the space agency to consider seriously protecting the far side. Because while the previous 3 applications are basically for scientific knowledge increased and all that, this one is about getting more precise measurements of the 6 orbital parameters of every asteroid and comet that we know about when they fly around the sun. And this is extremely important because when we know with high precision what is the orbit of this object, we have more time to prepare a space mission intended to deflect the object before it collides with the Earth. Now, I know that there are arguments, you know, the probability is low, the dinosaurs died 65 million years ago and all that, but that is just I'm sorry to say so because I'm a mathematician, but that is just mathematics. It could happen now, today, because we don't know many of these objects in the solar system. And actually, it happened in the past that some of these objects already were discovered after they flew around the Earth. Unbelievable. So we are so ignorant that, honestly, I would push on the planetary defense aspect as a key new element beside the other three elements to achieve moon Farside protection. After this, I thank you very much again for attending this conference.
Thank you, Claudio, for the final presentation and comments. Do we have any comment, question, contribution from the audience? Yeah.
Yes, thank you. This is Dario Kubler. Claudio, I think I was thinking that apart from the needs of clarify the key subjects of the treaty, there is also another interesting subject. I don't know if this could be included into this conversation, which is about the cooperation of nations on occupying or using the very few resources we have at the moon in terms of available craters on the far side, also on the poles, on the south pole. So we saw yesterday that there are many interesting ideas to build big telescopes, hyper telescopes, and also mining. And the numbers of available sites is quite limited. So the cooperation around who's gonna occupy which crater is also another important piece of the worldwide conversations around what we are going to do once we will have the technology to develop those things and building those interesting devices on the moon. So do you think this should be put into a conversation, or there are two different
I certainly think that should be put in the conversation because, you know, we all scientists know what we are doing, but the lay people, oh my goodness, forgive me, and the politician may not know what they are doing. Of course, I'm being cynical, and I apologize about that, but this is the situation. So yes, in the final version of the proposal, I would certainly put sentences like this to have the attention of the non-scientifically skilled people. So my answer is yes, thank you. Good. Oh, yes.
Thanks for the nice speech. Just an observation, a consideration, just to share what is the view of the astrophysics community with respect to the selection of some disposal strategy for satellite orbiter that we discussed before. That usually, but not only orbited, but also lander that have a moon impact strategy, just more or less on the far side.
Yeah.
So what is your position also in the perspective of this treaty in front of this selection?
Well, my position is that we approach the United Nations just because of that, because it's the only form of government above the national government. And the only hope we can possibly have to put some kind of peace among the rivalries that we live on Earth. So this is the answer. Now, of course, there is no guarantee that the United Nations will be able to convince the national government. However, let me say that having been working on this field for about, the first time I went to the United Nations was in 2010, so 15 years ago, I could notice a change in the attitude of some government. China did a wonderful mission when they landed for the first time on the Farside, because they opened a new step in the competition. Of course there is rivalry, but who cares? History is full of rivalries. That always happened. And they were much worse rivalries than this one, you know, wars and all that. Now, the point here is that, in my opinion, the governments are fairly responsible, including the United States government, that is NASA and all that. What scares me are not the governments. What scares me are the private companies, especially growing up now in America, because they have this, in my opinion, distorted vision that those who have the money in America can do whatever they please. Now, this is not acceptable outside America. And, you know, America is the best country in the world, and I agree about that. But we have to try to change this mood, at least as far as we can. It's difficult, I know. But look, we are not alone in this fight. There is not only science on one side and private interest on the other side. The reality is that we are finally realizing that we are living on a small planet. This is also the first time that we are trying to do something about another celestial body. So my hopeful conviction is that we'll make a success. It may take 10 years, 20 years, 50 years, who knows? But if we keep going this way, sooner or later, also the blindest people will realize that this is the only practicable way to overcome difficulties in spaceflight and in moon utilization. Thank you.
I share your fear, and I have a question, therefore. And the question I ask in aerospace industry conferences is this. The motivation for a civilian space agency is to succeed with high reliability in whatever it is their mission. You know, that's the sign of real success, and their budgets are much less limited. The motivation for a private enterprise is to deliver something that's adequate to do the job and to make some return for their investors and to show that they can do that rapidly and effectively and have a sort of tolerable loss rate, so to speak. So we want to preserve that far side of the moon, which has a lot of requirements that make extra cost on mission components, you know, shielding electronics and shutting off your transmitter for half your orbit. I mean, there are complicated things to do. What's an incentive system for a profit-oriented company to do that job well? Because it adds extra cost.
Let me reply by another optimistic view, okay? We could try to encourage worldwide cooperation about the moon Farside protection. For instance, by establishing prizes, asking spacefaring companies to design and possibly to launch whatever, spacecraft and so on, doing good science from the Farside, And we could have a prize, for instance, for the best success. It doesn't matter whether this belongs to the Western countries, to the Eastern countries, to Russia, to whatever. We are forcing a change in the mind of the policymaker. This is what I strongly suggest. It may be optimistic at the moment, I know. It may be utopistic, if you like, but nevertheless, it's the only way that we can hope for a change in the attitude, making all the spacefaring countries realize that they are part of a unique small planet in the solar system, and so they have to behave with responsibility in approaching the next celestial body in the solar system.
I'd just add that commercial companies still exist within countries, and there we go. Commercial companies still exist within countries, and to get a space license, they have to adhere to the country's obligations to international law. So that's why it's important to get those regulations right, to make sure they're flown down in such a way that companies adhere to them, and the countries enforce them accordingly.
Well, that's true. Again, we need, for instance, I don't know whether it is existing already, I hope it does, but anyway, we need a registrar of all these space private companies, wherever they are based on the world. And a declaration for each mission: we would like to go this place, we would like to do this, this, and this, and this. We need these instruments, and if anyone would like to contribute, they are welcome, and things like that. Now, this already exists, for instance, for the ships in the sea. I mean, it's all public. The navigation in the seas is for everybody, although practically in these days there is someone not disagreeing on that, but nevertheless, this is mare liberum in Latin, all right? So we need something like that also for space mission conducted by private companies. Okay. So, yes, please.
I'm Sebastiano Sandari from Polytechnic of Turin. I have a question regarding those protection regulation for the far side of the moon, in particular about who should grant those protection, because to do something like that you need some kind of power, both political, military, economical. So we should make sure those rules are followed by everyone.
Well, my answer can only be one: the United Nations Copywas, because this is the highest worldwide organization about space missions and all that existing on Earth at the moment. Of course, we'll have to convince the director of United Nations Copywas that this is a good point, but it's not impossible. It's just a matter of time, but, you know. And I hope that the young people will help us old guys to achieve this. Sooner or later, it will be achieved. Let me make a comparison, please. I mean, the gentleman from Berkeley University knows perfectly that about 50 years ago, SETI was a difficult topic to preach, right? You know, you can... I've not been doing it quite that long. Well, I mean, we in Italy had exactly the same problem. It was just Stelio Montebugnoli from Medicina Radiotelescope and myself preaching SETI in Italy. And of course, quotes, the distinguished astrophysicists, I am talking about 50 years ago or more, were cordially disliking us, you know, they were laughing, smiling, whatever. But nevertheless, 50 years afterwards, that does not exist anymore. SETI is a perfectly acceptable discipline in Italy, in the United States, and so on. So it's a matter of time. In other words, the people and the scientists and the copious scientists and lawyers have to get more mature. This requires time because it never happened in history before. We are facing a crucial period in history just when you know, we just after the end of the Second World War, all people lived all these horrible things of the Second World War. So just a few decades after that, it was hard for many people to change the attitude to space flight. I remember I was a 20-year-old guy, and we were watching the Americans getting down on the moon, and my father said to me, but you realize that they are walking on the moon? This is a revolution in itself that nobody was expecting. So I hope that that won't take 50 years again as for SETI, but sooner or later it will happen. And I am strongly suggesting the young folks in the audience, please think about that and act about that while you are young to open new prospects for the future. Thank you.
Thank you. This may be my lack of understanding of the shielded zone and the moon, but think 100 years into the future when maybe solar system travel is more prevalent, there are maybe outposts on Mars or beyond that. How does RF emission protection play into the wider solar system? Because the shielded zone and the moon is defined by visibility of the Earth, but if you've got activities beyond that, potentially outside that environment, is there any risk of limiting the ability to explore the solar system by implementing regulations now?
Well, we'll become, and we are already, conscious of how weak we are. There is a famous sentence by Tsiolkovsky, the Russian guy, you know, saying, the Earth was the cradle of humanity, but you cannot live the whole of your life in the cradle. And this is precisely the point. We are expanding now to the moon and to Mars. It will be sometimes pretty soon, some decades, put it this way. But that's just the beginning. If I can tell you something, last year I attended a conference in Toronto, and Niccolo was with me, about interstellar travel. That's another field that is being looked as you know, ridiculous, because nobody can go across an interstellar distances at the moment. But this is at the moment. You know, technology makes such a fast progress that it's just a matter of some decades and or centuries. Let's put centuries. I don't want to be conservative, but nevertheless, the progress will make its course unless we become crazy enough to start a nuclear war. Thank you.
Well, I am a pragmatic person, as you know, and I think that the major problem for the moment is that if we want to go to the moon and stay there, and to Mars to stay there, we should solve the problem that these are bodies without any magnetospheres, and so they are very vulnerable from the point of view of what my dear sun can do.
Yes, certainly. I agree. Thank you so much for the contribution. Yes. So, shall we close at this point? I don't know.
If no one has any more contribution, I think that just let me mention that I want to thank you, the artists, the people at the reception and that is servicing in the room, the audience, the speakers, the sponsors, and the supporters, the technicians for the video and the audio, and of course, Claudio. Thank you all for participating. For those that will be part of the IAC Milan at the end of October, we've submitted a special session on the moon Farside protection, and hopefully you'll be attending this event. Well, it's still to be accepted, but we hope so. And that's the first appointment that we can give about the moon Farside Protection Permanent Committee. Thank you all. It was a very pleasure to have you here, and hopefully we'll meet again for the same subject with many, many, many updates.
That's it. So please be ready to come back again in 1 year's time. Thank you so much.